All right, so welcome back to Chemistry Lab, everybody. So Dr. Burks here. So in this lab experiment, we're going to be going over radioactivity. So radioactivity is basically just whenever an atom emits some kind of particle or some kind of radioactive ray from within that atom. So you don't really need to know too much about radioactivity. In this experiment, we're just going to be looking at three different types of radiation: alpha, beta, and gamma radiation. So we'll be looking at these three types just in a very qualitative sense and comparing them to each other in regards to how strong they are relative to each other, as well as when you change the distance, how does changing distance affect their radioactive ability, as well as when we shield, meaning when we put a material between our detector and a radioactive source, does it change or block that radiation? So we'll look at different types of shields that we're going to use and see how that affects each of these three types. So alpha radiation, which is a positive particle that's emitted from an atom. The source we're going to be using in this experiment is americium-241. So it's a radioactive isotope of americium. It is the white source that you'll see. So in the videos, we're going to have these little discs that are the different types of radioactive source. They're color-coded, so that way you can keep track of what each disc is in each video. So if you want to come back and reference this, or quickly jot down this little table here, that we can keep track of what disc we're using. So white is going to be our alpha source, green will be the beta source, and blue is going to be the gamma source. Right, so if you see we're using the green disc in the video, that means we're using a radioactive isotope that emits beta radiation. So our alpha source is americium-241, like I just said. Our beta source is strontium-90, and then our gamma source is cesium-137. So these are the three radioactive sources that we're going to be using in this experiment. So during this experiment, it's going to be much more qualitative than what we usually use in a chemistry lab. So normally we try to be very quantitative and try to record all of the significant figures and try to be as accurate and precise as we can be. However, in this lab, we're just going to be looking more at qualitative trends. So when you're reading a ruler, you don't have to be so precise in looking at exactly the correct number of sig figs. You can just estimate what that ruler's reading is, for example. All right, so we'll just be looking at general trends as you change the distance. Does the radioactivity increase or decrease? And you're going to make different graphs to represent this data in your lab report. All right, so you'll look at the distance. You'll also make some graphs or tables containing your results from our shielding experiments and see how different materials act as shields, as well as how each source interacts with those different shields. All right, so let's get to it.